Welcome to Unit 8, and I know what you're thinking. I bet you've been waiting for this topic all semester. Sediment. Not to be confused with dirt. We don't use the word dirt in geology. Sediment. And we have to talk about sediment because our next rock topic is sedimentary rocks, and as the word sounds, sedimentary rocks come from sediments. Here are the learning outcomes for Unit 8A. Go ahead and pause the video and write these down. So sediments are the products of weathering, and weathering is breaking down rocks in place. The two main types of weathering that we're going to talk about are physical weathering, sometimes called mechanical weathering, and that is just taking a rock and breaking it into smaller pieces. Pretty simple. So we get smaller pieces of rock. Sometimes we break the rock all the way down to little individual minerals. And here are some pictures of rocks that have been broken down and are now considered sediment. The other kind of weathering is called chemical weathering, and as this one sounds, it involves chemical processes. Often water's involved and somehow either changes the chemistry of minerals in a rock or actually dissolves them, as is shown here, and produces what we call ions in solution, invisible. Just like if you took some salt crystals and you put them into water, they would, so to speak, disappear, right? But they really are just dissolving, and you've got sodium ions and chlorine ions in the water. The next video you're going to watch is going to be an overview of several different things, and I want to summarize them here so you kind of know what to look for. The video is going to begin by talking about chemical weathering, and again, that's the alteration of the internal structure of the minerals at the atomic level, and it removes or adds elements or ions. And there are three principal types of chemical weathering, and they're shown here. Dissolution, as it might sound, is when rocks are actually dissolved in the presence of water. And this commonly occurs in a type of rock called limestone, which is a sedimentary rock, which we'll get to soon. And limestone is particularly susceptible to being dissolved when rainwater is somewhat acidic. And here's a little cartoon showing some limestone. In geology, we typically use this brick-type pattern to indicate the rocks are limestone. You could think of this as the entire state of Florida. Florida is pretty much all limestone. And what happens is because it's susceptible to dissolution, you get little caves and caverns. If you've ever gone to visit any state parks that have caverns, they've undoubtedly been in limestone, although not always. And so what happens over time is you have these dissolution features. Sometimes you get sinkholes into them because you've dissolved away some of the rock. A second type of chemical weathering is called oxidation. Another word for oxidizing something is rusting it. This process turns iron-bearing minerals red. It oxidizes them. So when you see these beautiful scenarios like the southwest of the U.S. with all of these red rocks, they're red because the iron-bearing minerals within them, such as pyroxene, Ag, have turned red by oxidation processes. The third type of chemical weathering that you're going to learn about is called hydrolysis. And that word hydro should mean to you that water's involved. And this is when minerals actually break down and become clays. Some of the material gets washed away, and some of the material remains behind as a clay. And very commonly, feldspars become clay. This image shows some detail of clay that you couldn't see without the aid of a powerful microscope. What's interesting is that clay is a silicate mineral, and it's a sheet silicate, just like the micas. So you can see, when you look at this, that there are little sheets. They almost look like pages of a book that are sort of wrapped around each other and interlayered. And this is what a clay mineral is. On the bottom here should be a familiar image of Bowen's reaction series. And on the top, I have mineral and rock stability on Earth's surface. So we're looking at igneous and metamorphic minerals. And we've looked at igneous minerals. We haven't looked at metamorphic yet. Sedimentary minerals, igneous and metamorphic rocks, and sedimentary rocks. And we're just going to focus on this very first column of minerals that are common in igneous rocks. As we go down in the list, we have increased stability on Earth's surface. And that is because the closer we get to the bottom of this list, the closer we get to the bottom of Bowen's reaction series. So what does that have to do with anything? These high temperature and high pressure minerals tend to weather very quickly and break down at Earth's surface because that's not where they formed. They formed at higher temperatures and pressures than the ones down here, and so they're more susceptible to breaking down. On the other hand, these minerals down here, which represent the last few minerals to crystallize in Bowen's reaction series, are more stable at Earth's surface, and they tend to stick around longer. And quartz, in fact, is very, very resistant to chemical weathering, and that's why a lot of beaches are just pretty much quartz sand. The second kind of weathering you're going to learn about is physical weathering or mechanical weathering. I put both words in because they're used interchangeably. And this is a bit simpler. It doesn't involve any chemistry. It just involves taking a rock and breaking it into smaller pieces. So the three kinds of physical weathering you're going to learn about include frost wedging. And this is when the action of water that goes into the cracks of rocks freezes. And you probably know that water expands when it freezes. And so as a result, if water gets into cracks in the rocks and it freezes, it basically pushes or wedges open the rocks. And it can happen season after season until eventually you break away pieces of rock from each other. Another kind of physical weathering is called exfoliation. Now, I know you think about that word and you might think about your face and how people exfoliate the dead layer of skin on the surface. It is kind of like that. When rocks that are formed deep beneath the surface, like a granite, come to the surface, there's a release of pressure because they formed under high pressure, they get to the surface, and they start to peel away on their outer parts, almost like an onion peels away. Here's a picture of exfoliation weathering on some actual granite. Finally, there's some biological activity that can break up rocks, including root wedging. And this is when tree roots can open cracks in rocks. And I'm sure you've seen tree roots break up sidewalks. Well, same thing with rocks. So here's someone looking at some trees growing in some rocks. And over time, these rocks are wedged away from the cliff and they fall down here to the bottom. So these are all types of weathering. Now, erosion is a different term. Weathering, as I just said, is the breakdown of rocks and minerals in place, either chemically or physically. Erosion, on the other hand, is taking those broken pieces, that weathered product, and moving it to somewhere else, either by wind, water, ice, or gravity. And so you're going to learn about erosion as well in the next video. It's called Weathering and Sedimentation. It's from the City College of San Francisco. And after that, you'll come back to a video with me where we'll talk about environments of deposition.